So the first thing that they give here is this picture. This is a picture of a function. Domain, that is your input. Range, that is your output. This is actually a picture of what an algorithm would look like. So if you think about your computers or your phones or whatever you use, you are input something in your phone or your computer is outputting something. It's based on like a, if you do programming, so we have 8th and 9th graders, y'all are either in computer or you have taken computer. You have an algorithm, right? So you're telling the computer like a yes or no question. It is answering it. It is going through a loop, potentially coming back out until it gets the answer that it needs to continue on to the next thing. That's what a function is. You have an input. That input gives you an output. All right, so a function rule then is an equation that pairs each member of the domain with an element of the range. The rules that you have seen look like example 1 here. They gave us a domain, -3, -1, 0, 2, and 4. The function rule is this right here, f of x equals 3x plus 2. What is that telling me? Well, if I put an x in order to get my output, I need to multiply by that x by 3, and then I need to add 2 to the x, and I will get the output. We have done this. We did this on our last quiz. I take my input. They gave me -3, -1, 0, 2, and 4. I put it into my rule. 3 times -3 plus 2. 3 times -1 plus 2. I get a list of output. One of the ways I can list an output is this x, y, right? Those are my coordinates. Another way that I can show an output is a graph, right? Another way that I can show an output is a mapping diagram. These are all just showing my input and my output based on my function rule, okay? And so we're just looking at some terminology here, but we have done all of this. We have done input versus output. What we're really going to be looking at in this section is not given the function, but given the input and output, can I figure out what the rule is, all right? And so they give one more example. They give us this function, and they say, give me an input and an output, but they don't give me the numbers. So in this case, they use the same 5 numbers, but you'll notice up here, they just said graph it. And we talked about this a little bit, but we didn't really do it on our quiz. But when they do not give you your x's, like 5 numbers, then what you can assume is that it is any set of numbers that work. If they use the same 5, they're still going to come up with a table. They're still going to come up with points. The difference here is they are going to connect those points, because now all of a sudden they didn't say, hey, I only have 5 inputs that I want you to consider. They're saying, I want you to consider every input that you can put in from -infinity to +infinity. And the only way you can show that is to use lines and arrows. So while we chose these specific points to put into our function rule, and we got the y values and we plotted those points, we are now connecting those points with a line to show that we could have chosen any point, because they didn't give us 5 specific ones. So we could have chosen 0, which we did. 1, we didn't, but we could have. We could also have chosen 0.1, 0.2, 0.3, 0.4, 0.5, anything in between 0 and 1, right? And so if they do not give you a handed set of points, the way that you show that particular function is to connect those dots. You'll also notice we have an arrow at the end. That is the only way you can tell me it goes on infinitely, because clearly you cannot draw it infinitely. All right, and so that arrow says not only could I have done 1, 2, 3, 4, 5 and everything in between, but I could do 500 if I wanted to, and I could plug that in as well. All right, and that's what these arrows tell me, that I chose points to get a picture of what it looks like, but I also connected those points to say, hey, it actually includes every single number in between and infinitely in both directions. And so that's the difference in this section, is that now it's going to take away those inputs and it's going to start saying, now I just want you to graph the function. All right? All right. So now we're moving to, they have not actually given us the function rule. What they did is they gave us the input and they gave us the output. And our goal here is to figure out what is happening to the input that creates the output, all right? And so the first thing I do is I say, well, what's happening between the x's? How do I go from -2 to -1, and from -1 to 0, and from 0 to 1, and from 1 to 2? Is there a pattern? What are they doing to go from one to the next? Yeah, what are they adding? They're adding 1. And so we have added 1 to each of these. Now let's see what they're doing on the bottom. On the bottom, we went from -6 to -3. We went from -3 to 0, from 0 to 3, and from 3 to 6. What are they doing down there? Adding a 3, and you'll notice it is the same all the way across, okay? So every time this one increases by 1, this one increases by 3, which means that if I were to take my input and I were to multiply by 3, I should get my output. And let's see if that works. If I take -2 and I multiply by 3, what do I get? Right, and it works all the way across. -1 times 3, -3. 0 times 3, 0. 1 times 3 is 3. 2 times 3 is 6. And so the way I could write this rule, and we are using function notation because it said f of x, to find my y value or my output, I would take my x value and I would multiply by 3. And that would give me my function rule. So they have not given me my function rule and an input. They have actually given me an input and an output, and they are now asking me to find the rule. All right? So we're going the opposite direction here. They're giving me the x and the y, and they want me to find the rule. How do I get my y given my x? What do I do to it? All right, let's look at another one. All right, find the function rule for the graph. All right, now if they give me the function rule for a graph, we have not done linear equations yet. And so what I have to do is I have to come up with my x and my y. All right, and so I am actually going to create a table here, just like they gave me up there. And I am going to create an x and an f of x, right? And so I'm going to create an x, and I am going to create an f of x or a y value. Remember, this is the same thing as y. All right, and I'm going to do that all the way across, except I'm actually going to pick certain numbers because obviously this goes on forever. And I'm leaving a space in between for a reason, all right? And so what I'm going to do is I'm going to pick some numbers, all right? So I'm going to go on this particular graph, and I'm going to say, well, let's pick this number right here, all right? And then we will pick this number. You'll notice I'm picking ones that cross directly. We'll pick this number. All right, we'll pick those. By that, I mean I'm going to figure out my x and my y value. So my x value here is -4. That's my input. My y value here is -1. All right? That is my output. All right? Let's look at the next guy. This is -2x value. So that's what I'm going to put here. And my y value here is what? 0. So that's what I'm going to put there. What about this? What's my x value? My input? 0, and my y value? It's 1. Next guy is 2 and 2. And then my last one is going to be 4 and 3. All right? All right, so let's look at this and see how it changes. So how do I go from 4 to -2 to 0 to 2 to 4? What am I doing to all of those? I am adding 2, right? All the way across, I'm adding 2. How then does this change? What am I doing here? All right. Now here's the thing. If I go from -4 to -1, I cannot multiply by a 2, right? That's not going to work. All right? So sometimes you have to find a line in between, all right? In between. The way you find it in between is you take this one over that one, all right? So now I'm going to say this guy is going to represent, this middle one is going to represent 1/2 times my x. This one I did 3 over 1, 3 over 1, and I got exactly what I needed, all right? So I didn't have to do anything else. Now I'm going to do how y changes over how x changes, 1 over 2. So now this is going to represent that one, that line, and we're going to see if then we can come up with a pattern. So 1/2 times -4, what does that give me? 1/2 times -4. Half of -4 is -2. Half of -2 is, half of 0 is, half of 2, and half of 4. All right? So the first thing you're going to figure out is what did you multiply by? It's always going to be this number at the bottom over this number at the top. All right? So for this one, I did 3 times x, and I actually got exactly what I needed. For this one, I'm going to do 1/2 times x. All right? Now, when I do 1/2 times x, did I get my y value? Well, no, not yet. I got -2, -1, 0, 1, and 2. But now I'm going to look for a pattern. Can I go from here to here? What happens this direction now? So how do I go from -2 to -1? What do I do? Does that pattern work all the way across? -1 plus 1. Yep. 0 plus 1. 1 plus 1. And 2 plus 1. All right, so what does that tell me? Well, if I take this 1/2 x and I add 1, I will get my output. Now we're going to see if that works for all of them. And if it does, we have our rule. So I'm going to try my -4. Does that work? 1/2 times -4 plus 1 gives me -1. Yep, that works. Do you see how I'm checking it? I'm going to take the -2. 1/2 times -2 plus 1. That gives me 0. Yep, this one works. So I have come up with my function rule. I've taken this line over that line to create that center, and then I'm seeing what do I need to add or subtract to that to get the rest of my function rule. And so this would be my function rule. And you can see this one's a lot more difficult than that one, because that one, just doing the y over the x gave me my rule. But this next one, I had a secondary line because then I had to add or subtract to that rule. All right, I wasn't done by just finding what I was multiplying by. I had to add or subtract as well. All right, find the function rule for the ordered pairs. All right, so I'm going to look at this one right here. My x value is -3, and my y value is 9. All right, we're going to look for a pattern first. My x value here, -2 and 4. I'm just writing down my points, -1 and 1. I'm going to move these down some so I don't run out of room. 0 and 0, 1 and 1, 2 and 4, 3 and 9. Do you see a pattern? What's the pattern here? What am I doing to x to get to y? It's obviously not adding. How do I know I'm not adding? Well, 3 plus 6, right? -2 plus 6, that works, but then it breaks apart right here. -1 plus 6 does not equal +1. 0 plus 6 does not equal 0, all right? But I am doing something to that x that works for every single one of them. What am I doing? I'm squaring it. So if I were to do this particular function, I would say, well, if I have my x, all I have to do is square it. So sometimes you'll see a pattern between your x and y's that will go straight to your function. And you don't have to do, okay, 3 plus 1 plus 1 plus 1, because your plus 1s are not going to work. All right? All right, you're actually subtracting 5, then you're subtracting 3, and then you're subtracting 1, right? You're not actually getting a pattern other than some odds there. All right, so sometimes you'll see a pattern between your x's and y's. Sometimes you'll need to see what you're adding, and you'll need to create a row. All right, so I want you to try one. Write a function rule for this. Write a function rule. All right, absolute value is a special type of function that we are going to be graphing. What's nice about absolute value is they always look exactly the same. All right. They gave me this particular function rule, f of x equals the absolute value of x, and then they gave me these 6. And so if you plug it in, -3 plugged into the absolute value is 3, and you'll see that you get that all the way across. And you get something that looks almost like that x squared. The difference between an absolute value and x squared is x squared actually kind of curves a little bit, which we're going to do those later on. Absolute value does not. It's a very sharp V. Okay, it actually turns sharply like a V. And so if you connect those lines, your absolute value function will always look like this. It may be skinnier and it may be wider depending on what you do to it. It may move around the graph, but it will always look like a V. Sometimes even when you get, we're not going to do it this chapter, but it will flip upside down, but it'll still look like a V, always. All right, and so some things start to happen with this where you don't actually have to plug in the values. The first one they did is, you'll notice to this one right here, they took the absolute value and they added a 4. So if you were to plug that in, you get these particular x and y values. When you graph it, you get this. You'll notice what happened to the absolute value. This is what it looks like when it's just an absolute value. When I added 4 on the outside, what happened to my v? It moved up how many units? 4, okay? And so when you have an absolute value, you don't have to plug in 6 different numbers. You know it is going to be a V shape. It's going to always go up 1 and over 1. You see how it's a perfect little up 1 over 1, right? Because we're not multiplying it by anything. But if you add on the outside, it moved it up, all right? It moved it up. What do you think would happen if I had subtracted 4? It would have started at the 0, 0, and it would go down. This little guy right here is called the vertex. If you can figure out where your vertex is, you can graph your absolute value. Your vertex always starts out at 0, 0. If on the outside of the absolute value you add or subtract a number, it takes that vertex and it moves it either up or down. And then once you find your new vertex, you can just draw your V, and you have graphed this particular function rule. All right. So then if I were to give you this, write the function rule, well, we automatically know it's an absolute value. What do you think I'm going to do to that absolute value? Subtract 2, because it moved down 2. And so that would be my function rule. I don't have to get an x and a y. I don't have to say how do they compare to each other. I automatically know this is going to be an absolute value. All right, let's look at the next example. On this one, we added a 3, but now it is inside my absolute value. My +4 and my -2 was on the outside, right? This +3 is on the inside. Now this moves a little differently than you would think. First of all, here's my original. How did this move? To the left by 3 units. So when it is outside, it moves it up and down. When it is inside, it moves it left and right, and it moves it opposite of what you think, all right? The +3 moved it left. You would naturally think it would move it right, but inside the absolute value, it actually moves it left, all right? And so again, I know I have an absolute value. I can say, well, this is going to move it 3 places. Now I know it's going to be 3 places to the left. If it had been -3, it would have moved it 3 places to the right. That's how absolute values and really all functions work. So for this one, it wants me to write a rule. I know I have an absolute value. It has moved left and right, so I know I'm going to go inside. It moved right 1 unit. What am I going to say on the inside? Subtract 1. That is my new function rule. That is my new function rule. It can move both. It can move left and right and up and down. So if you look at this one, I'm really just trying to figure out where my vertex is, all right? And so what you can do is you can say, all right, my vertex will be the x value will be the opposite of that. So what is my x value for my vertex? Well, it's going to be +2. My y value is going to be whatever this is, in this case, positive 1. So you will see that when we got to my vertex, we moved right 2, up 1. My new vertex was at the point 2, 1. And then all I had to do was draw my v. All right? So when you have a known function and you know what it looks like, you can translate it. That's what it's called. When you're just shifting it around the graph, you're translating it. All right, so I want you to try these 3. I want you to graph them.